Have you ever stopped to think about what actually powers the packaging industry? I mean, every glass bottle, every aluminum can, that cardboard box on your porch, they all rely on this massive, invisible energy engine just to exist, way before they ever make it to a store shelf or arrive at a warehouse. And honestly, that engine is incredibly demanding. The containers and packaging sector relies heavily on high-intensity manufacturing processes. Converting raw materials into finished packaging means running processing units, glass furnaces, and cogeneration plants literally around the clock. To put it in perspective, for things like glass and paper packaging, energy alone can eat up a massive 15 to 20% of total production costs. Historically, and frankly still today, this huge scale of consumption is mostly driven by fossil fuels. And as we'll see, that creates an environmental footprint with some major operational and financial consequences. So welcome to today's Explainer. We're looking deeply at the environmental footprint of the containers and packaging industry. Specifically, we'll be breaking down the core operational topics laid out by the SASB standards: greenhouse gas emissions, air quality, and energy management. We're going to explore exactly why the industry's heavy reliance on fossil fuels isn't just an environmental hurdle, it's a massive financial and regulatory liability.
Okay, let's dive right in. Here's our roadmap for today. First, we'll look at the packaging energy engine. Second, tracking greenhouse gas emissions. Third, the impact on air quality. Fourth, financial and regulatory liabilities. And finally, number 5, strategies for mitigation.
Starting off with Section 1, the packaging energy engine.
Like we said, manufacturing packaging is a seriously energy-intensive business. Now, the SASB standards actually require companies to track their total energy consumed in gigajoules, but the sheer volume is really only half the story. Regulators and investors are laser-focused on the specific energy mix. Companies have to break their energy consumption down into 3 distinct slices. You've got your percentage of grid electricity, your percentage of renewable energy, and the total amount of energy generated right there on site. Since energy purchases make up such a huge chunk of production costs and overall margins, knowing exactly where this power comes from, whether that's purchased grid power, on-site fossil fuels, or dedicated renewables, is absolutely crucial for both accountability and keeping costs in check.
When making these energy sourcing decisions, companies are dealing with a really complex web of trade-offs. Sure, leaning heavily on fossil fuels might offer short-term reliability and maybe lower upfront capital costs, but it comes with a major catch. It directly impacts water use, it drives up air emissions, and it drastically elevates a company's regulatory compliance risk. So, a company's energy intensity, which is basically how much power they require to produce one single unit of packaging, directly dictates their long-term operating efficiency and their risk profile in a market that's getting more regulated by the day.
Which brings us to Section 2, tracking greenhouse gas emissions.
All this continuous, massive energy consumption naturally triggers a domino effect, leading us right to direct exhaust. The crucial point here is understanding how Scope 1 emissions apply to this specific sector. For packaging, Scope 1 isn't just about delivery trucks. It is overwhelmingly driven by on-site fossil fuel combustion. Whenever a facility fires up a natural gas cogeneration plant to keep paper machinery running, or operates a high-temperature furnace for smelting glass, those are Scope 1 emissions. It's the inescapable, direct exhaust from their core manufacturing operations.
And when it comes to complying with these rigorous reporting standards, rough generic estimates just won't cut it. Companies have to measure their gross global emissions across 7 very specific greenhouse gases covered by the Kyoto Protocol. We're talking carbon dioxide and methane, of course, but also highly potent industrial gases like hydrofluorocarbons and sulfur hexafluoride. To give you an idea of the scale here, sulfur hexafluoride, or SF6, has a global warming potential over 23,000 times greater than CO2 over a 100-year period. 23,000. All of these distinct gases have to be consolidated, calculated using those 100-year global warming potential values, and then disclosed uniformly in metric tons of carbon dioxide equivalents. So looking at the formal SASB metrics, the mandate to report gross global Scope 1 emissions actually comes with a really vital second half: the percentage covered under emissions limiting regulations. This distinction is huge. Companies have to rigorously disclose exactly what percentage of their gross emissions are actively subject to programs designed to limit exhaust, things like cap-and-trade schemes, carbon taxes, or strict permit-based command and control rules. This metric is quite literally where the environmental data collides with hard financial compliance and balance sheet risk.
Moving right along to Section 3, the impact on air quality.
Now, greenhouse gases are really only part of the story. The intense combustion of fossil fuels required to manufacture packaging also takes a heavy toll on local breathable air. Compared to a lot of other sectors, the containers and packaging industry is a surprisingly massive source of non-GHG air pollutants. And that's largely because of the specific chemical processes they use, like the kraft pulping process in paper manufacturing or melting raw materials for glass. The standards actually mandate the tracking of 4 very specific local pollutants in metric tons. You have oxides of nitrogen, or NOx, oxides of sulfur, or SOx, non-methane volatile organic compounds, known as VOCs, and particulate matter that's 10 micrometers or less in diameter. These pollutants don't just warm the globe, they trigger incredibly strict local air qualities permitting and directly impact the immediate health of the communities surrounding these industrial facilities.
Let's look at how this builds in Section 4, Financial and Regulatory Liabilities.
Tracking all this data, it is definitely not just an academic exercise. The financial implications are immense. Sticking to the status quo of high-intensity fossil fuel combustion creates some very real regulatory compliance risks. We're talking about operating costs skyrocketing from newly implemented carbon taxes, or aging, dirty facilities suddenly needing massive capital expenditures just to retrofit their equipment up to legal standards. Not to mention the severe regulatory penalties and halted operations if they fail to comply with local air quality permits. On the flip side, companies that proactively manage their energy and emissions reap some huge benefits. By driving greater energy efficiency or shifting to alternative fuels, these entities improve their operating margins, drastically cut their exposure to volatile regulatory risk, and honestly, they enhance their brand value in a market that is increasingly demanding sustainable, transparent supply chains.
Which brings us to our final section, number 5, Strategies for Mitigation. So how do companies actually tackle this problem and shield themselves from these mounting financial liabilities? Well, the SASB framework lays out a pretty clear, structured approach for how companies report their long and short-term emission reduction strategies. Step 1, set a base year. That is the concrete starting line against which all future progress is evaluated. Step 2, define their targets. This means deciding between an absolute reduction, lowering total tons of emissions, or an intensity-based target, meaning they want to emit less per unit of packaging as they scale up. Step 3, detail the actual mechanisms to get there. In the real world, this could look like a paper firm investing heavily to upgrade kiln efficiency, or a facility swapping its cogeneration plant from coal over to alternative biomass fuels. And finally, step 4, they must rigorously analyze and report their performance against these targets, giving regulators and investors total transparency into their transition plans.
All of this leaves us with a pretty critical question to ponder. As countries worldwide roll out increasingly strict environmental regulations to limit emissions, the financial burden on high-intensity manufacturing is only going to grow. For an industry that literally powers the delivery of almost everything we consume, how will the mounting costs of carbon taxes, air quality compliance, and energy transitions ultimately impact the everyday packaging you find on your own doorstep? The invisible energy engine of the packaging industry is stepping into the light, and its transformation is absolutely going to affect us all. Thank you so much for joining me for this explainer, and keep questioning the footprint of the world around you.